Dear students, under the topic double integrals, we are solving problems under the change of order of integration. Already we have solved problem 1 in our previous video lecture. Here we have problem 2. The question is to evaluate double integral over a given function by the method of change of order of integration. In order to solve this problem, first we shall rewrite this problem, the question, in a proper way in which we can understand the problem better. That is, here we have the limits. The outer limit, if we observe, is independent of any variable, whereas the inner limit, if we observe, it is dependent on y, and the other variable that we have in the problem is x. So therefore, since these limits are in terms of y, the inner limit is with respect to dx and the outer limit is with respect to dy. And so the first integral, that is the outer integral, is for y is equal to 0 to a, and the inner integral is for x is equal to y to a. And the question is x, that is a function, x divided by x square plus y square. And since the inner integral is with respect to x, first we have this given question is with respect to dx and then with respect to dy. So we have rewritten this problem just by writing dx and dy with respect to the limits given in the first and the second integral. Now this is the question given. Now here we have to change the order of integration. That is, here in the given question, the order of integration is dx dy, which has to be changed as dy dx. That is, the inner integral is with respect to x over here, whereas we have to change the order of integration in such a manner that the limits of the inner integral will be for y and the limits of the outer integral will be for x. For that, first we shall write the older limits and sketch the region of integration. So first we have to write the old limits. So if you see here, the older limits are for y equal to 0 to y is equal to a, and the inner limits are for x is equal to y to x is equal to a. Now having this data, we have to sketch the region. And we also know that the outer integral gives the movement of the strip for the older limits, and the inner integral gives us the length of the strip. And since it is with respect to x, that is the length of the strip is for x, the variable x, we understand that the strip is drawn parallel to x-axis for older limits, whereas now we are going to find the new limits by changing the order of integration. So for that, first we need to sketch this region. So let us sketch the region first. So in order to sketch the region, first I have taken the x-axis and the y-axis. So this is the x-axis and this gives us the y-axis. So having this, now let us sketch the region. So what is the first equation? Y is equal to 0. We know that the equation of the x-axis is y is equal to 0. So this is the first equation. So this axis. And the second is y is equal to a. So at some distance there is a constant value a. So this is the origin 0, 0. So 1, 2, etc. it goes on. And there will be a constant value a for y. So a point 0, a over here. So that is the equation, that is the line drawn at that point gives, so at this point I am drawing a line. So that gives me the line y is equal to a. So I am done with these two, that is y equal to 0 is the x-axis and y is equal to a is this line. So we have drawn, and we know that x is equal to y is the line that passes through the origin, and for every point of x there will be an equal distance of y also. So that let me draw here. So if you see, So I have drawn the line y is equal to x. So this is the line, that is the first line, x is equal to y. For every point of x, there will be an equal point of y, because of which we get this line. And next is x is equal to a. So x is equal to a is some point on this axis, but we have to understand that the point of intersection is this, where this line is y equal to a and this is x equal to a, and therefore at this point the coordinate will be a comma a, because when we put y is equal to a in this equation, we get x also to be equal to a. So this point of intersection between these two lines is a comma a, and therefore the coordinate over here, just that is this coordinate will be a comma 0, and therefore this is the line x is equal to a. So we have drawn this line also. I hope how you would have understood how we have drawn all the lines, and therefore what will be the region that under integration, it is this region which will be under integration. So I will just shade the region and I will show you. So this is the region of integration, and we know that for the older limits, the strip is parallel to x-axis because the length of the strip is for x. So that will strip is parallel to x-axis. Whereas now we are going to find the new limits, and so for new, that is because we are changing the order of integration. Now for the new limits, the strip has to be drawn parallel to y-axis. So I have drawn the strip parallel to y-axis, and therefore how the movement of the strip will be, it will be like this. So if you see, this will be the length of the strip here, it keeps on moving like this, and at a particular point this is the length of the strip, and as it moves till here, it will be to the fullest length till here. So the movement of the strip gives us the limit for y, and the length of the strip gives us the limit for a movement of the strip gives us the limit for x, because it starts from this point and it moves until here. So it keeps on moving until here. So x gives us, the limits of x are taken from the movement of the strip, and the limit for y will be taken from the length of the strip, since the strip is parallel to y-axis. So remember very carefully this concept. So now we shall write the new limits. Now since we are going to change the order of integration, the limits for outer integral will be for x. And x is the movement of the strip, that is the strip moves from this point until this point. So it moves from 0, that is here the value of x is 0, and here what is the value of x? A. So it moves from x equal to 0 to x is equal to a. Now we shall find the limits, and this is obtained from movement of the strip, and it will be just opposite to the older limits. So it will change its position. So the movement will be with respect to x and the length will be with respect to y. So next will be the limits for y. It is the length of the strip. So where it starts? It starts from this line. So all values of y at over this line is y is equal to 0. So the limit of y starts from this line and it goes up to this line. So what is y equal to here? Y equal to at this line is x, because this equation of this line is x equal to y, or it can also be said as y is equal to x. So from y equal to 0, from this line to this line, touches this line. So to y equal to 0, and this is obtained by what? By the length of the strip that we have drawn. So as per the old limits, the order of integration was what? Dx dy. Now as per the new limits, the order of integration has changed as dy dx. So first we will be integrating with respect to y, and then we will be integrating with respect to x, since the inner limit is for y and the outer limit which is obtained by the movement of the strip is for x. So now we shall evaluate the given double integral with respect to the new limits. So now what we will do, we will write this double integral with respect to this function, and then we will write the new limits. So I have written the function here. Now if you see what is the outer limit, it is for x equal to 0 to a. So 0 to a. And what is the inner limit? Inner limit is for y, which is 0 to x. So 0 to x. That is, this is y equal to 0, y equal to x. And now what is the order of integration? Dy dx. So this is dy dx. Now we shall evaluate this integral. So now first we have to integrate with respect to y. So we will just rewrite this. So it can be written as integral 0 to a. This x will be constant in that case. We can take it out. And when we take this constant out, the integral will be like this. Integral 0 to x. First we are going to integrate with respect to y. And we will rewrite this denominator as y square plus x square, so that we can apply a formula. And then we have dx. So now we have to integrate this. Now by the integration formula, we know that. So this formula we all know, that is integral d theta by theta square plus a square is equal to 1 by a tan inverse of theta by a. So using this formula, at the place of theta we are having y, and at the place of a, that is a constant, we are having x. Because since we are integrating with respect to y, this x will be like constant, and that constant is like a. So now when we apply this formula over here, we get this to be equal to 0 to a. X is a constant, we can write as it is. And after integration with respect to y, here it will be 1 by a. At the place of a, what do we have? X. So if you see, a square is x square. So 1 by x. Then tan inverse of, here you have theta by a. So at the place of theta, here we have the variable y. So y by x. And this is between the limits 0 to x. Okay. And then dx. So now we shall apply the upper and lower limit, and we can cancel these two x, which is in the numerator and the denominator. So that is equal to integral 0 to a. So when we apply the upper limit, it will be tan inverse of, at the place of y we are going to put x. So x by x. Upper limit minus the lower limit. So tan inverse of, at the place of y we are putting 0. So 0 by x. So upper limit minus the lower limit we have done. But what is this? X and x will get cancelled, and we will get this to be equal to 0 to a. And here you will have tan inverse of 1 minus tan inverse of 0. And then dx. But what is tan inverse of 1? It can be written as integral 0 to a tan inverse of tan pi by 4. Because we know that tan pi by 4 is equal to 1 minus tan inverse of 0 can be written as tan 0, because we know that the value of tan 0 is 0. In order to get rid of this tan inverse, we have written in this manner. So that will be equal to integral 0 to a. We know that tan inverse of tan theta is theta, and so this will be pi by 4 minus tan inverse of tan theta. Theta here is 0, so minus 0. And then dx. Pi by 4 is a constant. Minus 0 is pi by 4 only. So if we take that pi by 4 outside the integral, so we will have integral 0 to a dx. So now we have to integrate with respect to dx. So when we integrate, we get pi by 4, and the integral dx is x, and this is between the limits 0 to a. Now we shall do upper limit minus the lower limit. So upper limit, if you apply, it is a, minus lower limit is 0. So therefore that will be equal to, so since this is 0, when we multiply this pi by 4 inside, we will be having a pi by 4. So therefore the answer that we have evaluated is a pi by 4. Hence we have evaluated the given double integral by using the method of change of variables, that is method of change of order of integration. So we have done the change of order of integration. We changed the limits. Using the old limits, we found the region of integration, and having the region of integration, we have found the new limits, and with the help of new limits, we have integrated the given double integral. I hope you would have understood this problem. Kindly follow the upcoming video lectures for more problems under this topic. Thank you.